There are two articles, 240.86 and 240.93, in the National Electrical Code, or NEC, addressing ground fault protection. Article 240.86 pertains to ground fault circuit interrupter protection for personnel. This section mandates the installation of ground fault circuit interrupters, commonly known as GFCIs, in specific locations to safeguard individuals from electrical shock hazards. Article 240.93, on the other hand, focuses on ground fault protection of equipment. It stipulates that ground fault protection must be implemented for equipment in particular scenarios to mitigate the risk of fire incidents. The presence of two articles with closely related numbers stems from the historical development of the NEC. As the code evolved and new requirements were introduced, existing articles were sometimes divided into multiple articles to enhance the clarity and organization of the information. In this instance, the original Article 240 encompassed both personnel protection and equipment protection measures. As the regulations for each protection type grew in complexity, they were separated into two distinct articles. Firstly, Article 240.86 specifically addresses personnel protection. Secondly, Article 240.93 focuses on equipment protection. Understanding the historical context and the specific requirements outlined in each article is crucial. By adhering to the guidelines provided in both Articles 240.86 and 240.93, one can ensure the safety of both individuals and equipment within electrical installations. Ground fault circuit interrupters, or GFCIs, are safety devices designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit. If a ground fault occurs, meaning that current is leaking to ground, the GFCI quickly interrupts the power supply, preventing a potentially fatal shock. Ground fault protection of equipment is designed to protect electrical equipment from damage caused by ground faults. A ground fault can occur when a live wire comes into contact with a grounded surface, such as a metal enclosure. This can cause a large current to flow through the equipment, which can damage or destroy it. Ground fault protection equipment typically uses a ground fault relay to detect ground faults and trip a circuit breaker, isolating the faulty equipment from the power supply. The NEC, or National Electrical Code, is a set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect changes in technology and best practices. The NEC is not law, but it is widely adopted by state and local governments. Compliance with the NEC helps to ensure the safety of electrical installations. Understanding the NEC is essential for anyone working with electricity, including electricians, engineers, and building inspectors. It provides guidance on how to install and maintain electrical systems safely and effectively. Articles 240.86 and 240.93 are just two of the many articles in the NEC that address safety in electrical installations. By following the requirements outlined in these articles, you can help to protect people and equipment from electrical hazards. Consider a scenario where a person is using a power tool with a damaged cord. If the live wire inside the cord comes into contact with the metal casing of the tool, a ground fault can occur. If the tool is plugged into an outlet protected by a GFCI, the GFCI will quickly interrupt the power supply, preventing the person from receiving an electrical shock. Alternatively, consider a situation where a large motor develops a ground fault. If the motor is not protected by ground fault protection of equipment, the ground fault can cause a large current to flow through the motor windings, which can damage or destroy the motor. Ground fault protection of equipment would detect the ground fault and trip a circuit breaker, isolating the motor from the power supply and preventing further damage. The evolution of the NEC reflects the ongoing effort to improve electrical safety. As technology advances and new hazards are identified, the NEC is updated to address these changes. This separation of Article 240 into two distinct articles, 240.86 and 240.93, is a prime example of this evolution. It allows for more specific and detailed requirements for personnel protection and equipment protection, ultimately leading to safer electrical installations. In addition to GFCIs and ground fault protection of equipment, there are other safety devices and practices that can help to prevent electrical hazards. These include arc fault circuit interrupters, RFCIs, surge protectors, proper grounding, and regular inspection and maintenance of electrical systems. Arc fault circuit interrupters, RFCIs, are designed to protect against fires caused by arc faults. An arc fault is an unintentional electrical discharge that can occur when insulation on a wire is damaged or worn. Surge protectors protect electronic equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip a circuit breaker and prevent electrical shock. Regular inspection and maintenance of electrical systems can help to identify and correct potential hazards before they cause problems. This includes checking for damaged wiring, loose connections, and other signs of wear and tear. Understanding the principles of electrical safety and following the requirements of the NEC are crucial for anyone working with electricity. By taking these precautions, you can help to protect yourself and others from electrical hazards. When working with electricity, always assume that circuits are live until proven otherwise. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Never work on electrical equipment while standing in water or on a wet surface. Be aware of the potential hazards of electricity and take steps to mitigate those hazards. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone. Ground fault protection, as described in the NEC, is not just a set of rules but a comprehensive approach to minimizing electrical hazards. It involves understanding the types of faults that can occur, the devices used to detect and interrupt those faults, and the proper installation and maintenance of electrical systems. Ground faults can occur for a variety of reasons, including damaged insulation, loose connections, and accidental contact with grounded surfaces. When a ground fault occurs, current flows through an unintended path to ground, which can create a shock hazard or cause a fire. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults as small as 5 mA and interrupt the power supply within milliseconds, preventing serious injury or death. Ground fault protection of equipment is typically used for larger electrical systems such as those found in commercial and industrial buildings. These systems often use ground fault relays to detect ground faults and trip a circuit breaker, isolating the faulty equipment from the power supply. The NEC provides detailed requirements for the installation of ground fault protection, including the types of equipment that require protection, the location of the protection devices, and the testing and maintenance procedures. The NEC also addresses the coordination of ground fault protection systems to ensure that the correct circuit breaker trips in the event of a ground fault. Proper coordination is essential to minimize the impact of a ground fault and prevent unnecessary outages. In addition to the NEC, there are other standards and guidelines that address ground fault protection, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide additional guidance on the design, installation, and maintenance of ground fault protection systems. The effectiveness of ground fault protection depends on several factors, including the proper selection of equipment, the correct installation procedures, and regular testing and maintenance. It is important to choose equipment that is specifically designed for ground fault protection and that meets the requirements of the NEC and other applicable standards. The installation of ground fault protection should be performed by qualified electricians who are familiar with the NEC and other relevant standards. Regular testing and maintenance are essential to ensure that the ground fault protection system is functioning properly. This includes testing the GFCI outlets and ground fault relays to verify that they are tripping within the specified time limit. The benefits of ground fault protection are significant. It can prevent electrical shock injuries, reduce the risk of fire, and protect electrical equipment from damage. By understanding the principles of ground fault protection and following the requirements of the NEC, you can help to create a safer environment for yourself and others. The ongoing evolution of electrical technology continues to drive advancements in ground fault protection. New types of ground fault protection devices are being developed, such as arc fault circuit interrupters with ground fault protection, or SIs with GFCI, which combine the protection features of both of SIs and GFCIs. These devices offer enhanced protection against electrical hazards. Furthermore, advancements in digital technology have led to the development of more sophisticated ground fault relays that can provide more precise and reliable protection. These relays can be programmed to respond to different types of ground faults and can be integrated with other building automation systems. The NEC is constantly evolving to incorporate these new technologies and improve electrical safety. The latest editions of the NEC include new requirements for ground fault protection, such as those for electric vehicle charging equipment and for renewable energy systems. It is important to stay up to date on the latest changes to the NEC and to implement them in your electrical installations. In addition to technological advancements, there is also a growing awareness of the importance of electrical safety. Many organizations and government agencies are working to promote electrical safety through education and outreach programs. These programs aim to educate people about the hazards of electricity and how to prevent electrical accidents. The combination of technological advancements, code updates, and increased awareness is leading to a safer electrical environment for everyone. Ground fault protection is an essential component of the safety strategy. By understanding the principles of ground fault protection and implementing the requirements of the NEC, you can help to prevent electrical shock injuries, reduce the risk of fire, and protect electrical equipment from damage. In summary, Articles 240.86 and 240.93 of the National Electrical Code are critical for ensuring electrical safety. They address the specific requirements for ground fault protection of personnel and equipment, respectively. The historical context of these articles reveals how the NEC has evolved to address increasingly complex electrical hazards. By understanding the purpose and application of these articles, and by following the guidelines they provide, you can contribute to a safer electrical environment for yourself and others. Remember to always consult the latest edition of the NEC for the most up-to-date requirements and to seek guidance from qualified electrical professionals when working with electrical systems.